So good evening. I was trying to see if this is gonna work. I hope you can see this once I post this later on. There was a couple things I wanted to add to this whole idle speed situation when it runs up and when it, and what's behind it. Because for, I guess, the not so electronically adverse viewer, it may be a little mystery on how this all works. So I thought I'm going to make a little diagram, and you can see this here. I'm not trying to disturb this picture. You can actually focus on it and absorb it. In the middle here, I got the idle speed control unit itself. That's that black box I had the other day. And that is sitting in the passenger side footwell right there in the front. When you pull that carpet back, right there, you can actually see it. It's sitting in there and you can pull it out. Now on that unit, if you remember this and you watched the other videos, I showed you this. I had the original one, which was manufactured in week number 44 of 1985, meaning that's one of the very first units which they had built. And I also said there it was weak, and what I meant by this, the current was no longer being supplied to the full extent of what it needs. And that's why I penciled this in here. You probably have had now a chance to look at this here. This is the idle speed air valve. That is the actual round thing with the two connectors on it, which opens and closes. That's the one which I adjusted on the front there with the sleeve tube, whatever you want to call that in there. You pull it out, and I pulled it all the way out. You have to be careful, and I'm probably idling a little bit lower than what I should be. So, but there is only a very small play in it, so if I would have come out only half, say like a millimeter instead of 2 millimeters, I might be more like in the 800 range. And but I wanted to see what the full extent actually was. But anyway, I had showed you the original control unit, and I said this was weak and it wasn't working, even though I had modified the idle speed air valve. So what I did is I winded up reheating all the solder joints in that unit, and I applied fresh solder 6337. That is important with RMA rosin flux, and that flux is important that you use that particular solder because it will rejuvenate the solder joints. They had corroded, and the only way you're going to get the corrosion out of the solder joint with the old solder being dull in a matte finish, basically, that is indicating that air has gone, oxygen has gone in there, and it has corroded, is by RMA rosin-based flux. And it comes in 6337 tin lead solder. I will put a link in there to a good solder which you want to buy, and a 30-watt solder iron will do it. And I reheated and applied that solder to every spot, and now the unit is working like brand new. I have to make another video of it, but that's something I needed to say. This is something I'm learning too, is any type of electronic device in these cars, say like from the 70s and 80s, almost any model you got, if that is made or was made by VDO, you're gonna have to reheat the solder connection. And the reason for this being is that VDO used a cleaning process to get rid of the flux, because they were run through a dip solder bath, most likely. That was not a wave solder process they used, and they used a very aggressive cleaner, and that cleaner damaged to a certain extent the tin lead solder connection to begin with, some 30, 40, 50 years ago. And that allowed air, oxygen to go in there and to penetrate the solder joint itself. That is besides of them using a base material on the circuit board, which is more like Pertinax, which is not fiberglass. Fiberglass was very expensive back in those days, and the Purdinux combination, what they're using on single and double-sided boards, was the what we consider in the electronics industry a consumer grade type material. And so if they would have used fiberglass like Bosch did, Siemens did on their circuit boards in these cars, they wouldn't have had the problems what you're having now. So the VDO stuff was of a lesser quality, but then probably back then no one anticipated that these units are going to last 30, 40, or 50 years. But it is easily fixable. Reheat all the solder joints with 6337 tin lead solder, electronic solder, with rosin core, RMA rosin core flux. And like I said, I will post a link in the comment section there below the video, so you can buy the correct solder. And a Wello's 30-watt solder iron, I will put a link to Amazon in there too. And you carefully reheat this, and when you see it bubbling and it gets a nice silver color, then you know you have rejuvenated your solder joint. That fixed it. Anything you find in these cars electronically and it got a VDO label, stamp, or whatever on there, you're probably in for a resolder job on all of them. I had it with the cruise control. I had it on the on this unit here, on the idle speed control unit, and on the speedometer too. That's another one, the entire speedometer unit and the RPM unit. This is all done by VDO, and I resoldered all of them. I had to rejuvenate all of them for this to properly work. Anyway, now that still works now with this here. Now here's the thing, is the current output between the idle speed control unit itself and the valve is about 700 milliamps to 1000 milliamp, 1 amp. Number 2 is plus, corresponds to pin 7, minus is 1 and 6. This is a pulse width modulated thing, and because of the nature of it, and this being a coil which is going only in one direction, it really doesn't matter if the polarity is maintained or not, because the shaft, if you remember, can go only in one direction. The anchor with the shaft pushing into the other shaft, where that plate which opens and closes that valve is connected to, can go only in one direction. If there was a bidirectional situation, you would have to maintain the polarity. In this case, it doesn't make any difference. And that is the only thing which controls your idle speed on those cars. Now the question is, what information does the idle speed control unit actually get? And there is, for one, the water temperature sensor, the coolant temperature sensor B11.2. And if you have worked with these before, they have a resistant range from 100 ohm when it is really hot, say like 120 degrees Celsius, when your water in there is cooking, or your coolant is cooking, to about minus 15 kilo ohm, not minus 15 kilo ohms, to 15 kilo ohms when it is really, really cold. And I'm talking minus 20 degrees Celsius, minus 40 degrees Celsius. That is in the sub-zero temperatures. Now, interestingly enough, the one sensor out of the two in there is actually connected to the engine control unit, the ECU unit, the computer, which is in the footwell to the right of it. And that unit actually measures the resistance, and then it puts out a voltage signal, which is basically from 0 to 5 volts in the entire range. And I put this in here. When the engine is at warm temperature, say like 85 degrees Celsius to 110 degrees Celsius in an operating range, you will measure on that pin when the engine is running 3.5 volts to 5 volts. So when the engine is cold, you probably, if it's real cold out there, you may measure 0.5 volts, 1 volt, somewhere in that range. And that circuit is called TF for temperature function. So that is how that unit knows on how cold it actually is, and that influences the behavior on how it actually controls the idle speed. The next one, of course, the most important one, is the rear crank position sensor, which is mounted on the bell housing where your flywheel is, and it picks up that flywheel has 4 nipples on it besides all the teeth, and each nipple creates a needle impulse, very short in duration, and that is the coax cable which comes from that crankshaft or from the crankcase back there to the EZL unit. That is your ignition unit, where the ignition coil is fired up with. And that EZL unit puts a signal out, converts these 4 pulses per revolution to a 50% duty cycle pulse, which varies in frequency. And the formula is 0.2 hertz per 1 revolution. So when you're idling at 650 RPM, the frequency you measure is approximately 125 hertz, and the amplitude of that signal, it could be 6 volt to 11 volt, sometimes a little bit higher, maybe 12 volt would be acceptable too. That's how it actually knows on how many RPM the engine is actually running on. Then the next one is to get the increase in speed in RPM by 50 to 100 RPM. When the AC compressor relay kicks in on terminal number 4, it applies a 12 volt signal to terminal number 3. That will tell the idle speed control valve unit to increase the idle speed by 50 to 100 RPM. Then, of course, the most important one is the throttle position switch. Idle contact, that is the normally closed one. It is, I believe, labeled Roman 2, and it is on terminal number 1, goes to 4. The COM on this, since it is a normally open, normally closed switch, is connected to chassis. So you have a steady signal here, and when that switch is closed, it will ground it. It will basically go to 0 volts at idle. If you measure this and you're at idle, then either your switch, or you're measuring a voltage on there, then either your switch is bad or you have a bad connection in the wiring. And then here comes a very important thing now. Until model year 88, the input number 1 was hooked up to your level, to your selector level, and in P, that unit knows then that you're not driving, or an N with the lockout switch. In any other thing, is it knows it is basically you're running or you're operating the car, and this way it knew, whether or not you're standing or you're parking or you're starting, or if the car is actually in gear. This was changed in 1988, and that's why they have 2 different units with the 2 different part numbers I showed you for these. The actual Mercedes-Benz numbers was changed. The later version has, instead of a 0 to 12 volt signal for selector in P or N, and 0 volts basically when it is in any gear, has a tacho output, and that is the same tacho output which goes to your cruise control, which is a 50% duty cycle, where the frequency, similar to here, equates to the miles you're driving. So the car knows now whether the engine is actually, the car is moving, like when you're at a stoplight, because the throttle switch is usually closed at that point, but the car's not moving. So now you know you're idling actually. And they changed it. That was one of the major changes. Before, they didn't know if you were stopped at a stoplight with the gear being in gear and you're idling because the throttle position switch was closed, or if you were decelerating, like when you take the foot off the gas and you're basically, it closes the throttle and you're starting to coast, to slow down. This unit, the earlier units, did not know the difference. That became only clear with when they actually were feeding the RPM, or not the speed signal actually in there, because this way throttle position switch closed and you're driving, miles, say like anything higher than 1 mile per hour, you're coasting. 0 miles per hour, you're standing on a stoplight, and idle switch closed, so it means you're standing. And this way, this unit could control the idle speed better in these cases, and that has to do with the deceleration switch and the enrichment process of the ECU and that sort of stuff. And then, of course, you have your 12 volt supply from the OVP, over voltage protection, that's your constant 12 volt. And then from the ignition switch, the start signal itself, and the ground connection. That basically is the entire idle speed situation you got. So you can rework this two ways. You can fix your unit very easily soldering with the correct electronic solder, a rosin flux 6337 flux solder, and by adjusting the idle speed air valve. You can go out first. If it gets too low, you can just carefully push it back in. You may have to work in 0.5 millimeter increments, but you have to remember, is just more often you pull that thing in and out, is more used this gets, and it may lose its holding capability in there, and then the valve may go out altogether. But then eBay got quite a supply of used idle speed air valves. That's actually the correct name Mercedes-Benz uses for those, ISAV, idle speed air valve, and the idle speed control unit, ISCU. So that's just it. I just wanted to throw this in to clarify a few things and to make it a little bit easier for the home mechanic, or for any mechanic who's not into electronics as much as I am, to understand this more easily. And I hope that was accomplished with this little video. This will be part 3. Thank you very much, and you have a great evening.